Thank you for joining us this morning or this afternoon. So this is the ODP User Experience Roundtable session. Unfortunately, this is not exactly a roundtable format, but the intent here is to have a discussion rather than just to go through slides. And so I have a couple of slides here just sort of to introduce the participants in this, but the intent here is to, is to make this a lot more interactive rather than just snooze through slides until lunch. So the folks we've got here, we basically have representatives from three different groups. One who are representing people who are actually doing application writing, people like Robbie and Petri, representing Cisco and Nokia. SoC vendors who are providing platforms that applications can run on, Taris and Bala predominantly. And then, the overhead, such as myself, Mike, and Maxim. So what we'd like to do here is really just sort of discuss, both ODT from an application perspective, topics like, what are the issues involving adapting existing code to run with ODP and performance considerations, as well as ODP from an SoC vendor perspective for things like, what are the issues with working with existing SDK frameworks and other types of implementation discussions. And I'd like to just sort of open it up for whoever would like to discuss some of their experiences and get a dialogue going with people of interest. I mean, are most of the people who are in here who are not immediately part of the core ODP team, are you coming to this from a perspective of you've got applications you're looking to write, or are you looking at platforms that you're looking to potentially support ODP on, or is it some mix? That would be something to discuss as well. I mean, Taris, did you want to start with just talking a little bit about the Keystones stuff?
Yeah.
Do we have microphones, or what's the?
So, from the implementation point of view, we had I started implementing it 1 year ago, and I was giving my initial experience in the Macau. Since that time, the ODP went through many API changes, and that one of the implementers' pain, because while ODP involved, we made a lot of fundamental changes in the API structure, so the implementation had to be redone almost from zero, and we had several such iterations. And the hope is that after 1.0 we are going to more or less fix our API, that the changes can be made in more incremental stages, so that implementation can also evolve incrementally. And during this year we made several try to split out the clean API headers, because that simplifies a lot the implementation of ODP, because last year all our headers had a lot of Linux generic or software centered details in there. So basically each implementation had to copy those headers and modify them. So when in parallel those API headers get modified with a high rate of changes, it's very hard to keep them in sync with your own implementation. So currently, after several tries, we we I think managed to split the implementation specific out of the headers, and that I hope will simplify a lot the next implementation. The biggest issue with this split was mainly like C language or C standard limitation, because inside the implementation we want to implement a lot of function as static inlines, but according to the C standard you cannot define the static inline functions after you have a like clean not static inline definition, and our API are made in the form of clean function definition without static inline modifiers. So you cannot just have clean headers which you are include in your implementation and then you get them implemented there. So that's why we had to make some tricks to get it right.
Well, that was certainly one of the points that Maxim brought up, and we've got a current slides here as far as the for those who are not familiar with the issue, the fundamental okay, is this working?
Yeah.
Okay. So the fundamental issue is one of how are API definitions efficiently implemented on various platforms. So ODP defines a lot of abstract functions for accessing things, various things like packet attributes, which should be most efficiently implemented as inline functions. However, it's a question of how do you actually make that happen on various implementations. And so the header split that Taras is referring to is what showed up in, I believe, the 0.10 release of ODP, where the APIs are include ODP API in that part of the hierarchy, but then platform overrides are available in two places and platform type diffs, so that's allowing for inlining. So Taras, what's been your experience as far as performance improvements with inlining? I mean, have you done any measurements or?
Yeah, I haven't done any measurements yet,
Okay.
but there definitely will be improvements in. Yeah, and we are not. So another option is to use the link time optimization, but that should be tested and evaluated which one truly gives it, like whether the link time optimization will give you the same performance and it will end up with the same result as like direct static inlining.
Mm-hmm. Well, that was certainly I don't believe Leonard is here, but that was certainly what he reported with his experiments. So.
But I guess it's useful to have this API split anyway, because now the API definition is clean.
Yeah,
and it can be reused by different implementations.
They are not 100% clean, but the structure is in place. So as you have posted the timer cleanup, so there are some models which just still have software like Linux generic details inside of them, but that can be splitted on like iteratively when it is really needed by some implementers. But the main thing that structure is in place and it seems to be working fine. I'm just in progress rebasing my implementation on top of this structure.
A lesson we learned at Cisco is definitely I was just going to say a lesson we learned at Cisco was our code base that started out on an internal proprietary core. That tool chain actually supported lane time optimization in place, and so we structured the code around that. And then when we tried to target other devices that didn't necessarily able to do that and needed static inlining to compile efficiently, it was very painful to go back and remedy that. And so I think even if everyone today could do link time optimization, I think you still need this split to be able to give that flexibility to not exclude anything. Tool chains in various states of development, that kind of thing.
Sure.
I've also seen some issues with this that in OVS, yesterday we discussed it, that with Frankie, in OVS, in the hot pass, there is a call to ODP packet LAN, which is supposed to say, tell you how big is the actual packet, which is normally, it's a short function, but if it's not inline, it shows not a huge but a detectable performance problem, and making it inline is actually not trivial, because that particular function implementation uses DPDK types, for example, and also internal types of the implementation. So if you put it in an inline function into a public header, then it's not going to compile with your application, because your application will complain that it couldn't see the definitions of those structs and other accessor functions which are internal to the implementation.
Well, I know that you're working on optimization of OVS for working with ODP, and we'll be talking about that tomorrow, which of course will be an interesting discussion that we'll be looking forward to. So are you saying that the inlining structure that currently exists, you believe still needs improvement, or that it's just up to the individual implementations to figure out how best to use that intelligently?
Our best idea yesterday was so far to just copy that information, that piece of information inside the implementation to a place which is accessible for the application. I haven't tried it out yet, but if we can work it around, then we're not going to have this problem of that we cannot inline functions, because they contain definitions which you cannot see.
Well, yeah, I mean, we have within the implementations the notion of internal include files, right, which are things that are intended to only use within the implementation, but the platform definitions here are effectively part of that implementation, so use of internals should be permitted there. As I said, it's not something that an application should be using directly, because if you're referencing internal includes, obviously you're sacrificing portability. In some cases that may be justified, but we'd like to avoid that as much as possible. But within the definition of an ODP API, okay, that's a perfectly legitimate use of an internal include. So unfortunately, if it's included as part of the include chain in a C program, there's nothing which would prevent an application from using it. We don't have the sort of type hiding that say C++ would provide. But again, a little discipline should cover that, I think.
Yeah, I was thinking also about that as a possible solution. One problem might be that still we have, in case of ODP DPDK, for example, we are relying on yet another outside libraries, structs which are defined inside the DPDK source, which then would make your application to need to include those somehow, which is, in case of OVS, it's in the compile system, it's not that straightforward to just tell them that you should include this.
Yeah. Well,
yeah, it's the same with the Keystone implementation. In that case, you need to define some other stuff to be able to compile OBS. So the problem of compiling ODP applications, read-like applications, that are ported over ODP is, there's more aspects to it. It seems like you can come up with a nice way of building the application without being aware of the underlying ODP implementation, at least of the SDK in our case, because the PDK and the SDK
Can I?
is not.
Yeah, so if you are going to inline some functions, like to make direct calls from ODP to SDK, you anyway have to expose the SDK headers, right? So, but you are not, you're exposing them through the ODP headers. So the application normally will include only the ODP headers, which then below include some SDK. So when you're compiling your application, your SDK should be in the search path somewhere. So they should be accessible when you are compiling. In this sense, yes, the application should kind of know that there is some SDK, and it should also add the search path to the SDK when it gets compiled. But from the code, you don't refer to the SDK directly.
Yeah, and there's one more thing too. It seems like there's a bit of duplication when you're compiling ODP and when you're compiling Open vSwitch, for instance. Because I'm thinking, talking about this real life example. You have to pass the same defines to the compiler, the same paths, include paths, the same search library, and the same library. And if you happen to get one of these wrong, then you might not get the right object out. So maybe we should be able to improve that to. It's still not easy, but anyway, perhaps having a makefile.inc. I know that we have that in platform, but how somehow being able to source that into your makefile or whatever, so that it takes the same arguments that were passed when compiling the ODP the ODP implementation. Take the same arguments and pass them to when you compile the ODP application. Because otherwise you might get in trouble. I haven't actually tried that, but for instance, in your SDK, in the TI SDK, you have to define device underscore k to something, and you might just get that wrong for some reason. I don't know what's the effect for that, for instance.
Yeah, you should define it exactly the same, but the point. So I'm not an expert in auto tools, but currently we are using libtools, and it at least save the dependency, the library dependency. Basically, it has included all SDK libraries which you needed, but it doesn't include the all defines and the header search path.
That should be, now that you mention it, I remember that you should be able to extract the compile flags and LD flags through package config, PKG config. So, but I don't think that we do that for ODP, the Keystone version at least. I don't think that we save those flags and LD flags.
Yeah, maybe it can be improved.
We have standardized header files that they're provided by the implementation with values from that implementation, and you're suggesting, Cyprian, that we have the same kind of solution for the makefiles, a standardized makefile name, but the content is provided by each platform with the defines and the libraries that's
it's
necessary for that platform.
It seems like, I think it's a standard tool with some the same. It goes hand in hand with auto tools. Maybe someone else could elaborate on that. But as far as I know, you just run package config. You pass. There's a .pc file that is created for each package, and that file contains C flags and LD flags, if I remember correctly.
Is there someone here in this room that's supposed to be looking at this? If you duck, Cyprian, who's behind you?
I could look at it, of course, but I just remember seeing that a while ago, and I remember now about it, but I think that's the way to do it with package config.
Yeah, I just want to add a few points to this. So this structure which we have recently developed in ODP helps because this gives the control to the platforms to define which functions to be inline and which not, which is something which is critical because few APIs might be inline for better performance. And one more point which I want to add, which is apart from this inline, is that currently in ODP 1.0 we have focused completely on getting the APIs which are suitable across multiple platforms. And one important point which we need to work on is also performance. So certain APIs might have better performance on certain platforms and certain might not be better performance on each platform. So what I would suggest is some kind of a validation tool, basically a performance testing tool which tests the performance of different APIs on specific platform. This could help the application writers as to know which APIs perform better on which platforms. And additionally, there are, from the start of ODP, we know that there will be 5% of optimization which has to be done for individual platforms to get the better performance. That factor has to be taken care, and each platform owners, each implementers will have to provide their APIs which they think will improve the performance on their platforms, and that has to be integrated into ODP, so that when an application writes an ODP app, it performs best on each platforms.
Just one question. So, any idea on how a typical application, a performance application, would look like? Something like what I'm going to is that you basically need, or generally need, something that runs between two hosts, so that you pass real traffic between the interfaces and do some measurements.
Yeah, exactly. So we don't need it for all the APIs. We just need for performance improvement APIs like ODP schedule, ODP packet send. So those APIs have to be tested, not classification, create, or destroy.
But even for the schedule performances, you would still, I guess, need someone to push packets into an interface so that you can see how fast the schedule. Or can
Yes.
you generate packets without involving the packet I/O?
Actually, it has to be tested in two levels. One without including packet I/O, another with involving packet I/O, so that it tests even the packet I/O also.
I would say one of the things we have to be careful of, if we start creating APIs that are better for a given, implementation, as long as we don't end up with 10 APIs for 10 implementations, because then we might as well just use the SDK. So there has to be a balance between portability and performance. It's I don't want to say lowest common denominator, but in some ways that is, that for that portability across implementations, applications have to be able to accept that there are, performance implications to that. You can't have it all. You want to get as close as possible, but it is sort of understood from an application level that for portability, you have to make some sacrifices.
Right, well, we've certainly, understood that to a certain extent in that, for instance, if you look at the various packet APIs, sometimes we'll have multiple ways that you could accomplish the same things, address-based offset, offset-based, access to a packet versus segment-based access to a packet. And it's understood that, a given platform may work better using one model than another, even though they all support it. So an application would still be portable, but if you're trying to tune the last ounce of performance out of things, which people tend to like to do, there may be a reason for choosing one approach versus another on a given platform.
One of the concerns, for me, from a porting application standpoint, is we have ODP packet I/O receive and ODP packet I/O send, and then we also have ODP schedule. I don't want to have to support getting packets through the one mechanism or through the other mechanism, necessarily depending on the implementation.
Right.
That one uniform way of packet work distribution, is ideal. So, that's one I still struggle with.
Well, and it's certainly the case that's going to be a recurring theme this year, because initially we were just trying to get the basic foundation in, and now, that's we're pretty much done with 1.0. I said for those who weren't in yesterday's meetings, our intent is that 1.0 will be done late this month, early next. But the goal for 2015 is now to really focus on the performance grade, optimizations and refinements needed to be able to use this in production.
I kind of agree with Robbie. Like as he said, the portability aspect of ODP is a key feature. But what I was talking about is that 5% of an API which are dependent on individual platform, which platform owners can sit together, they can formulate an API which can be implemented. So that from application point of view, you just still write a single app, but the amount of more optimization you need to do will be much less. That helps both ways.
And a comment regarding the packet send receive function and the schedule error. In my understanding, we keep the packet send receive to be able to easily migrate like legacy app application which used to work with sockets and which hard to refactor to use the scheduling method. So basically, if you can, you should always migrate to the schedule, because I assume that somewhere in future we may just drop the direct send receive.
I was going to comment the same thing as you, Taras, and I think all the legacy software out there does not use the scheduler if it's not proprietary software from companies that have used specific networking SoCs that have schedulers. So that's why we have the packet IO for all the other software. But I think we need good examples that actually use the scheduler to promote this programming model. And we need good ODP implementations on the kind of hardware that people generally have available, so they can see if there is any benefit of using a work scheduler. So we can spread this programming model.
Yeah, I mean, if we're trying to, some of the example apps, I think, like L2 Forward, have send and receive coded into them versus ODP schedule. And I can't remember. I think there's like maybe a pound define or something that flips it back and forth. But just from if these are examples of, hey, this is how to structure your application, we need to point out in there that yes, this is here, but don't use it. If you're writing something from scratch, do it this way. So it could be that it's really more of just a documentation.
I think that's
best practices guide kind of thing.
I think that's true. As soon as we've got the 1.0 API out, this year we have to tidy up our examples, because I think they're very poor examples. Some of them are based on ODP 0.1, and we really were coming from the model where you have packet IO. They just need to die.
So let me ask if there's anyone else here who has questions because we have people who've been using ODP to write increasingly sophisticated applications, as well as those who've been involved with implementing it on a number of platforms. So if anyone has questions, this is a good forum for getting that.
My interest is for driver perspective. Do I need to know something special about ODP? For example, do I need to call another function instead of native RX? Could I do NAPI? Could I do gyro in the driver or other stuff? Could I pass don't know. Is it generic support for fragmented frames on receive?
Yes. Maybe it wasn't clear from the beginning, but ODP is a framework which runs in user space. So it's not a part of Linux kernel.
Deal only with control.
No, it's data plane which runs in the user space.
So you basically not gonna have your kernel driver. You're not gonna have Natifrx receive and NAPI and these things, but you will have for packet I/O you will have a poll mode driver in user space, which does the same thing as essentially. Yeah.
But, what speed can be achieved? What throughput can be achieved in the user space?
Quite good actually. If you avoid the kernel, then as we could see that in case of OVS, it was a big plus that I will talk about that tomorrow. That in case of OVS, what were the numbers? But if OVS used the kernel module, the OVS kernel module to communicate with the kernel drivers, we could achieve something like I don't know, like 2 million packets per second. Whilst if it's used the OVS DPDK implementation, which used the DPDK library, which is implements a user space poll mode driver, then you could have almost line rate on a 10 gigabit per sec, which is like 13 million packets per second.
That is with smallest packets, right?
That's with like 64 byte small packets, switching small packets. Because obviously, if you have big packets, then your overhead is much less, and your problem that you are every time calling down to the kernel and coming back is not that painful. But if you are doing things with small packets, then this the switching between the kernel and the user space and everything which comes with that could be actually a big bottleneck.
So if I use if I use relatively large packets with 10 gigabit, I should be okay.
Yes, in that case, right now ODP doesn't give too much plus, I believe. It's rather focused to eliminate the overhead, which you can see if you otherwise if you would need to communicate a lot between the kernel and the user space.
Okay, thank you.
I'll just add though that even if you can, get close to that, just because I mean, obviously the small packet is sort of what people use in benchmarks because it's sort of the worst case scenario, and in the real world you obviously, I mean, the purpose of moving packets is to actually do something with the data, not just exchange hacks. While you can get better line rate utilization with kernels with larger packets, that still doesn't help you when you now move beyond 10G and start talking 40 or 100 or beyond. And so all of the stuff that ODP is doing is looking to forward as well to be able to scale to much higher speeds as well. So the idea being that because the APIs are not, I mean, while there may be a poll mode driver underneath, that's not something that the application sees, right? So the application isn't saying, oh, I need to call a poll mode driver, or I need to take something off of a ring. So any other questions or comments? Okay. So one of the other questions was, we, as some people may know, that we've got a number of different ODP implementations. The main one, Linux generic, is the odp.git repository. But there is a ODP DPDK repository, a netmap one, which is again somewhat experimental, not clear where we'll go with that. ODP DPDK clearly is going to become very important this year. And then there's the ODP Keystone 2 repository. So these are all the ones that are available as open source. Other repositories are the implementations are available, but the source is not necessarily available. So the question is this split, useful, and what else can be done to improve that? Mike and I were just having a discussion earlier of if we look at ODP being packaged into, for instance, RPMs, and now looking to go into a standard distribution, well, how does that affect, if you're trying to install multiple implementations of ODP on a single system? Because if you do a sudo apt-get install ODP, what do you actually get? Do you get Linux generic? Do you get DPDK? What if you want both? And how does that map into the various packaging architectures? I think that's one of the we'll talk about that a little bit this afternoon during some of the deep dive discussions. But
that's fairly easy.
That's easy. Good.
From a distro point of view, we can go through it later. Yeah.
Then it's a solved deal. Steve will show us the 2 lines it takes to make that happen. Any other questions or observations from folks?
Yeah. So regarding this split, it actually was nice idea because like having at time of split we had 3 or 4 architecture inside of one repo, and that significantly slowed down the API changes, because each change should address all platforms, and usually the author of this change doesn't have any experience with all other platforms except the pure software implementation, and this synchronization between that author and maintainer of each separate platform takes a lot of time, and we had very big time of merging patches, and after we split them, the rate of patches increased very significantly, and it's even now problem to keep up with updating implementation on the side. So
too slow or too fast?
Yeah.
There's another split we could do, because obviously ODP Git contains not only the API but also the Linux generic implementation. In my mind, in some ways it looks cleaner. There should be ODP Git, which is just the API headers, and then ODP-Linux generic Git, which is the Linux generic implementation.
ODP headers and verification tests.
Yeah. So in ODP, you would have the headers and the tests which prove that a given implementation conforms to what is expected. But is that a good idea?
I think we should do opposite. We should at some point we should collect everything.
Yeah, I have an opposite idea, and probably it was good for beginning to do such split, to define types and do some prototyping, and at some point we need to do like Linux kernel did, to collect all platforms together, and all changes will be most visible how they will be reflected on our platforms, and it's just an idea, but probably it's a good way to go.
So I sort of agree with Mike, but I think conceptually it would be nice to have that split. One of the questions I would have is the logistics of, if I'm introducing a new API now, don't I have a situation where I have to have 2 separate patches to 2 different repositories that must be synchronized, and whether that causes unique issues.
But that's actually advantage, that you will have 2 patches, so, and they can be asynchronous. I mean, you will make changes to the API and tests, and then the Linux generic should be updated, or even Linux generic can be updated after ODP Keystone, for example. So that this breaking the link between change in the API and the Linux generic, it actually makes sense.
But in that case, it's difficult to
track this synchronization. So it's very easy to be unsynchronized.
But that's why you have validation suite. So you can basically run your updated validation suite on top of the Linux generic and see that it doesn't comply anymore. So you lost some patches.
Theoretically, yes, but it's good if everything in one place. But if validation suite in one place, there are different versions of validation suite for each API change, and there is API which is in different repository, and Linux generic will be in third repository. So it will be quite difficult to find synchronization point of 3 or 4 different Git repositories.
Yeah, but I'm not sure that you really need that synchronization. Yeah, we can discuss it later in our hacking sessions.
Yeah, actually it's long term to discuss because
I mean, it's a good point. I mean, that does. I mean, should it be further? Whereas the validation tests are themselves their own repository. I mean, you can keep obviously splitting things out, because it's a question of you have a validation level 1.0, 2.0, whatever.
Well, what happens now if a member company comes along, they have an implementation that's not public, and they've got some new fantastic piece of hardware. So they would obviously they may well successfully get that API available, and right now it might be very difficult to implement that in software. The only way we could move forward right now is they would have to put in the API. We'd have to put that API in ODP Git. We'd have to put in tests for it and a Linux generic implementation. Otherwise, it couldn't move forward. But if we split out the tests and APIs and make Linux generic its own platform, like Taras said, you decoupled it. Any of the platforms could be the first to implement the new API. You don't have to make a software implementation first.
Right. Yeah, I like that idea, especially as we get into some more sophisticated hardware assists, where, as you point out, it may be very difficult to create a reasonable software analog to them. So, for instance, if for instance in some of the future you wanted to capture the notion of being able to program an FPGA, okay, to augment the provide dynamic classification or other type of assists, it may not be obvious how you would model that in software. So, nor would it be particularly relevant because there'd be nothing you'd be offloading.
But wouldn't that in the end risk compatibility? Because if you get someone who spearheads and do that, you can't implement it on generic Linux, so you can't prove that any other can implement it in software to provide support for that API other on that specific platform. It's going to end up fragmented, and then it's no use.
I think it enables to move the API ahead. Somebody can send a patch or propose a new API. So it's easier to propose a new API and put that into send a patch to the API repo. It may be in a separate branch for a while before we have second and third opinion if this is a good idea. Maybe it's just if there's only one guy that can efficiently implement that, maybe then it will never be accepted as in a kind of release version. It may be as a work item there in the API repo for a while, but then we just decide to drop it. But it's there as code and kind of spec, not just the mail on the list that this is my idea. This is my idea. Here's the code or here's the API definition as code. Try it out on your platform. If it works, then maybe we accept it.
Or maybe a validation test that for the API that says this is how the API is intended to be used.
Yeah. So I think the question is, I think this API versus implementation split may make sense. the API versus validation split may not, but we could at least start with API plus validation, so that it's you have the spec and the test.
I'm just concerned that you end up with something that in practice there's a lot of API pieces that are essentially platform proprietary, although they are in ODP, but in essence they only work with one specific hardware.
Yeah, I think
So then why make the split?
But it's like to speed up the development, but still the end result of some of those branches maybe that it's a dead end.
But that's fine as long as this little group that does
Yeah.
it. But when you open it up to the world, will that still work if you don't have that safeguard? I think that that's if you look at the open source community, it's
maintainers.
it may yeah.
Somehow that there's a clear current official API.
Exactly.
Brands, and then there may be this kind of test branches that
Yeah,
add
but
new stuff, but they
Sure.
are not never merged into the official standard.
But that's a trunk. You can have that anyway.
Well, I think what Tobias may be referencing is that you may have a standard set of the ODP APIs for, like, say we have ODP
Right.
3.0, and,
Yeah.
and everyone supports that, but with this split, then there's no reason why vendor X couldn't say, oh, I'm the 3+, because there's
Well,
some.
they can do that.
Yeah.
But that's not
Right.
the official
Right.
latest version of ODP. That's an addition that might make it into ODP, and they have to do that. But what I'm afraid of, if you allow into the official version APIs that you can't realize in generically in software, then it's nobody has even a chance to support the function unless they have new hardware, which means it is a proprietary piece of extension that might never be realizable.
So are you arguing that splitting Linux generic out from ODP is probably not a good
Exactly.
investment? Okay.
It's not a
so
good
you
idea.
prefer to keep those
Absolutely.
together.
I think it's a good idea.
It requires
Yeah.
everybody to prove that you can at least create that function,
A reference
a
implementation.
reference implementation in
Yeah.
software for API completeness.
But to be devil's advocate, 10 years from now we have some amazing technology and 12 SoC vendors can all do this fabulous thing in hardware. That the reason it's done in hardware is because it takes 1 billion years to run in software.
Right.
Then you're saying we would never accept that as an ODP API.
But isn't that what we have with classification today? We have it in the API, but software-based implementation, classification might never have the performance of.
Well, yeah, I wouldn't expect the software to ever have the performance. That's the point why we did the hardware. But at least we were able to write it in software. I'm thinking.
Well,
sense.
I mean, no, it's not
Exactly.
like this isn't quantum magic, right? I mean, I mean, there will be some software description of it. I mean, Verilog is software of a different form, but the I mean, I see Tobias's point, and I think it's a good one that by forcing you to elaborate what the API is, even if you wouldn't run it in actuality, at least people would say, oh, this is what the API really means, and I can now use that perhaps as a model to see how it would map to my hardware, as opposed to
verification for kind of compare equivalence verification.
I think it's similar thing that if you send an API Linux generic version only,
Yeah, of course, in
doesn't
software
prove
it
that
will take
it
1
fits
hour.
to other
Hardware,
implementations.
couple of couple of
it's
micro,
just-
but who cares?
I think anyway, any standard API function that is gets the standard status, it's our decision as a group that it's good enough definition so that everybody can efficiently implement that. So one implementation like Linux generic doesn't prove that you have to have multiple. But it's kind of the question, do we always have to have the Linux generic implementation there, and do we always have that as the first one, so that you cannot post or merge new APIs and test cases without Linux generic implementation? If let's say Keystone implementation exists for that already, but not the Linux generic. But so I don't know, can we kind of keep track track on these kind of proposals that are not yet standard work in progress, and then.
I mean, I sympathize with your point, and definitely you have to be able to do that, but I think there's, you know, for all sorts of development, I think you don't want to have to rely on a specific hardware to write an application using a specific function. It has to be possible to at least functionally test it without executing on that hardware and prove that it runs. But then, agreed, I mean, that's how you have to set up some sort of experimental branch or trunk branch, which is typically common in a lot of projects. If you have these type of, hasn't made it into the main line yet, but it's there for people who want to try it. So I think that's something, you know, a lot of ways to set that up, I guess.
There's also the aspect of people who might want to look at the API just to get a rough idea of how the architecture was, you know, designed. And just makes a bit more difficult a first-time user to clone the API repository and then, oh, I need the platform soon. And yeah, I mean, it's one step, one additional step, but
Yeah, it's a little more self-contained.
Yeah.
So you at least have a complete system, because the API headers by themselves are not particularly useful.
Yeah, and at least for 1.0, because right now we're 1.0, we don't have a production grade version. 1.0 is really a good version that we can give out and let people have a look at it. So at least until 2.0, I think it's actually better to keep it self-contained.
The thing is, if you've got the headers and the test cases, then you do have a lot of information about how it's supposed to work, and I think you could then do without a Linux generic implementation.
Yeah, but I think every user would like to at least test the application.
You can't run those verification tests without some implementation.
I mean, it's one additional step, but I don't know, someone might just thought, it's kind of stupid, I need to find a repository, and to find the platform, I need to pick up the right version that syncs up with this version of the API and so on.
Well, it's sort of like the standard C library, right? I mean, if you have math.h but no implementation of it, you know, what is that telling you?
Yeah, and this, I mean, there's also this aspect of matching the versions. So, I mean, might be troublesome.
I think a company that can spend thousands of hours or more specifying, designing, and verifying a functionality in hardware, they should be able to provide a software reference implementation as well.
Yes. Yeah. Which they probably started with anyway.
Yeah.
But it's kind of just I think the benefit is that would be the unlocking of the dependency or the delay to the Linux generic implementation, so that if we can agree on a new API and put that definition there, other people, all the platforms could start implementing that on the same headers before the Linux generic implementation is ready. That's kind of the
yeah, but I see that. But I see that as a feature that's what do you call it? It's kind of forcing that delay makes also maybe room for a little more. Yeah, otherwise, people will rush ahead, and you know, the experience as I see it is that that's kind of built-in. What do you call it? And forces a little bit of makes it more stable over time. Otherwise, people will spearhead. We will have, you know, things that are not realizable on other hardwares. It's
or conversely, because several platforms are implementing it simultaneously, you'll find those problems faster. So I think different APIs, different bits of hardware, one or other model works better. I don't know what, we need to find the one that most frequently is useful to us.
I think we can just simply put ODP unimplemented macros into the Linux generic implementation if we don't want to be ready with that by the time we do the API specification. And in that case, everyone can see the API and use the new API definitions. You will have a big marker in your code that you need to complete something. But if you want to do it in the other way, to make the Linux generic implementation first, then you can do that first. Or if you want to implement it first on your another platform, then you can just send in your patches and stub out Linux generic.
Yeah, but I mean, it's open source. Everybody can provide their, out of tree version with additions, right? I think that's okay. But I think that the key is say what's the official version and not, because what I'm afraid is that we sacrifice compatibility for speed, and I think that's a very stupid mistake, because then the whole exercise is futile to begin with. So I just want to make sure we have the safeguard for compatibility, because otherwise it would be more efficient to write to the metal, right? And that's not the reason we invented ODP.
I think what I mean about this putting just stop implementations, dummy implementations for Linux generic is just for until the next dot version of the API comes out, and you can also say that if it doesn't provide the Linux generic implementation by the deadline of that release, then we will just remove those patches and it's not going to be part of the API.
As is often the case with our discussions, they really get flowing just as the time runs out.
Yeah.
So what I was going to suggest is that we do have the ODP deep dive discussion session at 2 o'clock. That is in Bangkok. So we should resume there. We will have other things to discuss, but we can always fill in with more of this. Thank you very much. It's very helpful.